today we looked at the product rule and we looked at a number of examples on the board. So I'm going to start with the most basic ones that we looked at. So one of the ones we looked at was something like x squared plus 2x multiplied by x squared plus 2. So we had a look at this and we said that the product of two numbers is when we multiplied them. So we're looking at a way of differentiating an equation or a function like this using a rule. And we saw that the rule said that if you have two things that are multiplied, u times v, that goes to, and it's in your log tables, u multiplied by dv dx plus v multiplied by du dx. Now, what are u, v, and dv dx, du dx? What is all of that? Well, if we have a look at what the product rule tells us, it tells us that when we multiply two things together, u being the first one, in our case that's going to be x squared plus 2x, v being the second one, which is in our case x squared plus 2, that will go to u, which we have and we know from our own equation, and v, which again we have and we know, and dv dx and du dx. I'm going to talk about that now. So dv dx and du dx, that notation means differentiate v or differentiate u with respect to x. So we'll have a look at what that means now. So looking at the first one, what I would do is I would write out u equals, and I would write that out as a little key for myself at the side. U is equal to x squared plus 2, and v is equal to x squared plus 2x, or sorry, x squared plus 2. So that's what we have. Now, du dx then, if we were to find du dx, that again means differentiate u with respect to x. So here is u, and here is what is the function or the equation that will generate u for us. We will need to differentiate that with respect to x. So it's as if it was dy dx, but instead of calling it y, we've called it u. So we do the same thing as we normally would, multiply down by the power, take one off the power. So that's what we get here. In the other one, we get, so in the other one, we're going to get dv dx, which works out to be, the differential of this is going to be 2x. All right. Now, this one here, to keep it easy and nice for us to keep track of things, I'm going to keep them color coordinated. So I'm going to change the color of this to an orangey color so we can follow that. Right. So what we need to do then, now that we've figured out what du dx is and dv dx is and u and v, we go back to what the rule tells us, and that's in your log tables on page 25. We go back to that and it shows us exactly what we have to do. So it says that dy dx goes to u, which we know is going to be the x squared plus 2x, multiplied by dv dx, which we worked out to be 2x, plus v, so we're going to add v, so plus v, which is x squared plus 2, by du dx, and du dx is 2x plus 2. So that there is the product rule subbed into. So we've used the rule from page 25 of the log tables and subbed in. The next step is just to tidy all that out and multiply things out. So we've got these two multiplied together. Well, I'll get 2x cubed plus 4x squared, plus on this side I'm going to get 2x cubed again. So I've got 2x cubed plus 4x plus 4. and tidying that up. So I group like with like and I add those things. So if I do that, for example, here I've got x cubed and x cubes. So if I tidy those up, I'll get my 4x cubed. I have no other x squareds, they're on their own. So I'm going to write 4x squared plus, I have no other x's, so plus 4x on its own plus 4. And there we have our final answer. So it's just about using this rule here, selecting your u and v, then differentiating them as they are, and using the rule then to sub into. So let's try another one. Let's step it up a bit and we'll do one with a square root in it, which you found a bit tricky today. So let's take a look at one of those. So for example, if I had the square root of x, so let me go back, we must always write y or f of x equals. So y equals the square root of x times x squared plus 2x. Okay, so keep it nice and simple for the rest of it. So the root x, right, when I'm writing that out, I would remember that I can write root x as x to the power of a half. So using my indice rules, I can write root x as x to the power of a half. And now it's much easier when we go to differentiate. So again, what we would do is identify our u and our v. So I'm going to do that. My u is x to the power of a half. And my v, which is the second thing I'm multiplying by, is x squared plus 2x. And if I sort that out, then I'm going to have over here u equals, so let me color coordinate that again. So we've got u in pink. U is equal to x to the power of a half. The other one we have is in blue, which is v. V is equal to x squared plus 2x. And the other parts that we need then for our equation when we're subbing in for dy dx is I first need to find dv dx here. So dv dx, which means again differentiate v with respect to x. So if I differentiate v, which is all of this, with respect to x, I'm going to get 2x plus 2. And the other piece is du dx. So I then have u differentiated with respect to x is going to be, now multiply down by the power, take 1 away from a half, take 1 off the power, and we get minus a half. And what we do then is we start to assemble our final answer here. So we start to put in our u, and remember u was x to the power of a half. Our dv dx, which is in green, and we said dv dx was 2x plus 2 plus v, so I'm going to add v, which is x squared plus 2x, times du dx, and du dx is going to be a half x to the minus a half. All right, and then we multiply this out. Now we have to be careful because we have this x to the power of minus a half and x to the power of a half. So when we're multiplying, we need to consider indice rules when we're doing that. So when I multiply those out then, so dy dx, that becomes x to the power of a half times 2x, which gives me 2, and then it's going to be x. And then because it's the same base, indices with the same base, we add the powers. So a half plus, and if there's nothing there, there's a 1 there. Add those two, and I get 2x to the power of 1.5 plus 2x to the half plus, and now we're going to multiply these two guys. So being careful again with that, to the power of a minus a half. I'm going to get minus a half x to the power of, and when I multiply indices of the same base, I add the powers. So 2 minus a half then is going to be 1.5. And then I'm going to have 2 by a half is plus 1. X to the power of 1 by x to the minus a half is going to give me x to the power of a half. And then if I tidy that up, and we said in class today that we would think about, okay, I'm counting x squares, I'm counting x cubes, I'm counting x's, and it's the same thing then when you count x to the power of 1.5. those two guys can go together. They're the same thing. We're counting how many x to the power of 1.5s do I have, and I have 2 here and I have half of them there, so I get 2.5 or 2.5 x to the power of a half, or sorry, 1.5. That was the grey 1.5. And then the last one, then look, I have here 2x to the power of a half and 1x to the power of a half. They can go together because they're both counting how many x to the power of a halves do we have. And there is 3x to the power of a half there. And we can tidy that up for ourselves, or you can leave it like that. So this one here would become x to the power of 3 over 2 plus 3 root x. And using indices, then I could actually use this guy. I could say that this is 2.5 times the cubed root of x cubed. So it's going to be the square root of x cubed using the indices in log tables. 3 root x. Now, don't get too worried about this guy at the end here, this conversion here. That's indices. Revise the indices, but if you write your answer for now as this, that is okay. But try and revise indices over the coming days and be able to rearrange those, because you might start out with the question that looks like this and be asked to write it backwards. So do practice the indices. And again, you can do the exact same thing when it comes to having ln of x inside here, or a cos of x, or an e to the x. Have a go at those questions, and if you have any questions about them, do come up and ask.